We manufacture tools for bearing. As we know, the world turns on bearings. There's all kinds of bearings out there. And our mission is to make life of a mechanic who has to install the bearing easier. If they have to install it, if they have to remove it, if they have to replace it, our tools help to make it happen, to make it easy. So, what kind of bearings are there in the aircraft? Well, there's roller bearings, there's ball bearings, there's also spherical bearings. And mostly today we're going to be talking about the spherical bearings. The way we install bearing in the aircraft, we don't only push it into a housing or a mount. It's still an interference fit. It's a very close tolerance fit, but it's still not enough force to keep it in place. So the word retention comes into mind. To retain a bearing, meaning to secure it in place, not to be able to lose that bearing if there is axial forces working against it or vibrations. Back in the 60s, our company came with the idea of securing the bearings via flaring inward or outward some portion of a material, either from the bearing to the housing or vice versa, from the housing to the bearing. So there's all types of different tools that make it happen. The most popular one is the roller stake. Action of 3 rollers rolling around the edge of the bearing in which we have a groove. The groove creates an edge or flare that we will be flaring outwards toward the chamfer of the housing. And we will perform this operation from both sides of the housing. This way we'll make sure the housing is secure. All right, so that's the most popular and typical application of the tools that we manufacture and that we sell. But there's also situations where we have to exchange or change the worn bearing, correct? So we're talking about a total bearing replacement. And this procedure is not so easy. It has to consist of relieving the bearing in order to push it out. And since the edges of the bearing are flared outwards, secured from both sides of the housing, we have to cut them off. How do we do it? We have all kinds of cutters. They're very precise, very precision devices that basically penetrate the bearing and the bearing only. So they feature a pilot, which is basically oriented 90 degrees toward the surface of the bearing. And it basically slides right on the pilot. You cannot move it left or right. It just goes straight into the bore of the bearing, only cutting the lip that was swedged before. All right, so first we're gonna cut that lip off. And this is a sample of what the cut lip looks like. Okay, so typically customer would just mullet it out or take the hammer and just step it out. This is not a good way of dealing with precise aircraft parts. Again, we're dealing with airframe, engine mount, aileron, flaps, or whatever part of landing gear is it. It's a delicate part still. It's very precise mount. Therefore, we have a device that pushes the bearing out. Call it the ASEER, and ASEER stands for Aero Staking Installer Remover. Basically, this remover is going to push the bearing out simply by turning the nut on the other side. So it will suck the bearing in to this little cup. All right, so we remove the bearing. We'll clean the bore. We'll make sure that the cutter didn't do any damage. We will install the bearing. Installation of the bearing is basically pushing it in. But again, let's remember that this is a very tight fit. You can not just push the bearing in with your hands. Impossible. And again, mechanics do it by tapping and roll it around, and that's not the way to go. Because there's a tendency to move, to cock. So the alignment, the true alignment of the bearing is the keyword here. And in order to align it correctly, again, the Acer tool comes to us. Basically, we'll put the pilot through the board, and that establishes an axis, a perpendicular axis on which we will be pushing the bearing into the bore. All right. So this way we are not scraping off the edges of the bore. We're not doing any damage to the housing, to the mount. It just slides smoothly in. How so? Well, basically, again, same action. Just push and start cranking it in, like so. So once the bearing is installed, now we have to retain it. Now we have to make sure it will not fall off. The types of retention, depending on the type of bearing, are the roller swaging, staking by ball impressions, spherical impressions, or segmented impressions. There's also an old way of doing it by basically flaring the edge of the bearing by one hit of a hydraulic press. We call it Anvil Staking. We do not recommend this method, and there's many reasons why. If I started talking about it, this would be an hour-long conversation. But we can give everybody details why we do not recommend Anvil Staking and why roller swaging is the better, more controllable, a safer, stronger way to go. So once again, a typical swager that features the 3 rollers. This is the portable style that mechanic can do it on wing, mobile. And there's also a machine version, basically a drill press machine operated device that basically uses the quill of the machine, comes down right in the center of the bearing and start penetrating that very groove on the edge of the bearing and flares it outwards. So this is like a cold working of the material, so it makes material stronger. It basically doesn't crack the material because it's not a direct hit, if you will. It's a smooth rolling action. All right. So either to do it by the machine, or we can do it by hand. When we do it by hand, we simply install it onto the mount like so, secure it with a nut, and we can use all kinds of wrenches. We can use a crank that we could provide, and that's how easy it is. You just basically give a couple of turns on one side, a couple of turns on the other side, and the bearing is secure. Now, how do we prove that this is secure strong enough? How do you know that the quality of the swage is acceptable? Well, this criteria, accept or reject, is being checked by something called proof loader. And proof loader is basically a device that tries to do nothing else but tries to push out the bearing. So we will be pushing this bearing out with a certain force. Who determines the force? Usually OEMs or engineering ad sheets, drawings, manuals will tell you how much force you have to try to push the bearing out with. We are measuring it electronically with this Megatronic device called proof loader. So it's battery operated, battery is charged. We connect the RS-232 to it or USB. We turn it on. It calibrates itself because the unit, the electronic unit, the meter, communicates with the load cell that is installed within this envelope of this adapter device and reads the calibration value. It will show you the serial number, it will show you the poundage value. What we do here with the bearing, this basically indicator is in contact with the bearing itself. It sits tight on the housing, so it basically records what's happening to the bearing. So once I'm going to start using a regular wrench and give some poundage to it, I can read what the poundage is right here in the display. This device will show me if there's any linear movement of the bearing, either going up or down, or if it's moving at all. So there is some criteria. acceptance versus rejection of how much it can move. We're talking about, hair thickness of a movement. If it doesn't move, if it stays in place, that means the swedge was performed good and this whole process is accepted. And that basically covers the whole bearing replacement procedure. But this is for GSE, for MRO, for any type of application where we repair existing aircraft. For the new production, if you will, for the production floor, we will be selling these babies. These tools are the bread and butter of our company. It's called Triroller Swaging tool. And for the installation, your typical customer would be basically using this to install the bearing swedges from both sides. And they usually perform the proof loading on their own, or they will purchase this unit as well. So that pretty much covers like the most popular, most typical application. Obviously, there's many more. Our line of our products is very broad. So we won't have enough time to talk about each and every application, but I just wanted to mention that there's different ways of retaining the bearing in place. Again, you can zoom into this little impressions around the bore. These are called the segmented impressions. These are called the spherical ball impressions, line staking, anvil staking. This is another anvil staking right here. It's basically flaying out or in a portion of the material to make the bearing stay in place. So the main idea, again, is to secure the bearing in place or to replace a worn bearing. Another application is to test the bearing. Also, we can test the quality of the bearing itself by breaking its torque. What do I mean by that? There's two races in the bearing, the inner race, which is the sphere, and the outer race. And the inner race has to move or rotate freely within the race, okay? So in the process of installation of the bearing, sometimes it's possible to damage the bearing, to squeeze it too much, to deform it or such. So after the performing the repair, mechanic also is being asked to perform torque breakaway, meaning to be able to tell how much torque do we need to move the inner sphere versus the outer ring. Simple as that. So basically this little device goes through the bearing itself again, secures in place, and there is a torque wrench provided, which you have to zero out. And there's a memory arm that you have to zero out as well. And basically slug it in and perform a one move. And this thing records, right now it recorded 7 Newton meters, okay, of the torque. And again, we're looking at tables if it's accepted or rejected. Okay, so this is another testing device. And basically that would cover everything that we want to cover today. And the most popular military specification bearings are called MS type of bearings. There's two groups, MS 14101 and MS 14103 are the spherical bearings with the groove that we can penetrate the groove with the rollers. Okay, so these are the bread and butter again of our product. These are the best sellers. All right. Other than that, there's obviously a lot of application customs. They're custom, hard to get places, very limited space for tooling maneuverability, challenging applications, because then the tools have to change their shapes tremendously. Okay, so then we will work with your customer to provide us technical data as far as the drawing of the housing, environment around the bearing, okay? And this way, we will figure out what will fit, what will not. And there's all kinds of different solutions. There's millions of them. If you can imagine all kinds of shapes within a landing gear or engine mount within the aircraft, they get more and more complex year by year, especially since the additive manufacturing was introduced. We specialize in custom applications. We will be asking a lot of questions, unfortunately. They're kind of annoying, but we have to ask, we have to know what we're doing in custom applications. But other than that, the standard tools are super easy to sell. Basically, they sell by themselves. People are asking about them. They know they exist. They just don't know how to find them. So this is the the biggest challenge to find guys who sell. We are not salespeople. It's hard for us to sell. We are manufacturers. We're a bunch of engineers that sit there and create new solutions. We don't have time to be out there on the road and sell them. So we would like to ask you guys to do it for us, to spread the word that these tools are available. They make mechanics' life easier, and every mechanic has some horror stories about exchanging or replacing bearing in the aircraft. Let's make it easy for them. Let's make it easy for you. All right.
Do you have case studies on any of those situations?
Yeah, there's case studies. There's articles.
We can definitely share those with customers.
Right.
They can say, "Wow, we had that."
Yeah, Aerospace and Defense magazine was just by us last week, and they did a case study. They're writing an article about us.
Yeah, nice.
So it'll be published next month, I believe.
I think the custom aspect, they can customize, solutions.
Oh gosh, yes, yes. Again, yeah, we would put per application, obviously, the certain family of tools, not necessarily similar to each other, but something that is for particular application within the airframe, and put it as a kit. So our goal is to make an easy solution for customer where we would provide some big kit where he's got all kinds of cutters for this particular bearing, swagers for this, stakers for the other. One big kit, put a big logo name and nomenclature, and make it easier for them.
Last question I have for you is, if I understand well, your kits are approved by the OEMs in many instances, by the bearing installation process.
Mm-hmm. So yeah, the most popular specification for bearing replacement by Boeing is called BAC 5435, and until a couple of years ago, our name was in it. Because back then we didn't have any competitors, everything was going smooth. One of our distributors became a competitor. It's a long story, but anyway. Since then, they wanted to be included in it. Boeing said, okay, nobody's going to be in the specification. So basically, they took our name out. But we're still in the manuals of Airbus, Embraer, and a few of the military stuff. F-35s, Raptor, even the F-15 Eagle, which is being retrofitted right now. So yeah, our name is out there. Our name is out there. Government calls us all the time. Just like last night before I flew out from Chicago, I had a late night phone call from Hill Air Force Base to help them out with the AOG situation, aircraft on ground, which basically we had an immediate solution for them. They absolutely